Alright, good afternoon. We are now doing MSM 131, alright. We're continuing from where we ended. Okay. We're continuing from where we ended. Right, so basically we're dealing with polynomials, right? We're dealing with polynomials. We're now on question 31, right? We did 31A, B. Most assuredly, let's do D. Okay, so we'll do C, then E. Right. So what we are being told is that solve the following inequalities. Right. So a recap: we said an inequality is different from the way we treat an inequality is different from how we treat an equation. Right. So an inequality, the solutions are not exact. For an equation, when you solve it, you have maybe an x value being equals to 4, but for an inequality, it becomes a range. Okay, so it's from one point to a different point. So this is what we're now looking at. Okay, so C says you have 4x cubed plus 7x squared minus 2x is greater than 0. Okay, of course, that's what the question. In the question, you notice that this 2x is on the other side. I've already taken the other side, right? Basically speaking, what we're going to do is we're going to find the first factor. We taught you how to find the first factor is by trial and error, but we said that we can find the first factor by assuming that this is p, right? So p, the coefficients of p, the factors of the constant, right? Now, the beauty about this question is that you don't have a constant, right? So you can actually factor out the x, and what remains here will be 4x squared plus 7x minus 2, right? So the first part, you find that x is greater than 0, right? So meaning that you have 0 to positive infinity, right? So that's the first solution which you have. But since it says it's strictly greater than 0, instead of having an open interval, what we are going to have is, a closed interval, we're going to have an open interval. So the answer is 0 to infinity. That's your first, right? The second one, we are going to have 4x squared plus 7x minus 2. Okay. Product is -8 and sum is 7. So product is -8. Your sum is 7. So what are the factors? So sum is 7. The factors in question, we have. What are the factors in question? The factors in question is going to be 1 and 8. Okay, 1 and 8. But the 1 will probably be negative and the 8 will be positive, right? So now we have 4x squared minus x plus 8x minus 2. Alright, if you check out this, you can actually factor out x, which is common. You have 4x minus 1. Then you have the other one. If you factor out a 2 from here, you have 4x minus 1. So you have x, this is positive, plus 2. Let's just say 4x minus 1 multiplied by x plus 2 to be greater than 0. Alright? Okay, so from this, what are the x values in question. So you have 4x minus 1, x plus 2 is greater than 0. So what if it was an equal sign? We'll actually have x being equals to 1 over 4 and x being equals to negative 2, right? So these two values you are seeing here, 1 over 4, if I equate this to 0, so if we equate this to 0, then we'll have x is equal to 1 over 4 and x is equal to negative 2. Then these are now my boundary values, so we have 1 over 4 here, and we have negative 2 here, and we have 1 over 4 here. Alright, so how do I use those boundary values to get to my solution? Right, so what we're going to do now is we're going to test for values of x beyond. So we'll start with negative. We cannot test at negative 2 because negative 2 is not included, right? So it's strictly greater, so meaning this part is open. Okay, if it was closed, it would be shaded, all right? So it's open because it's strictly greater. So we are going to test a number beyond negative 2 or before negative 2, let's say negative 3. Alright, so we have 4, negative 3, minus 1. Okay, this is negative 12 minus. I'm just interested in the sign, whether the sign is positive or negative. So we have negative 12, yes, negative. This is negative 12 minus 1, negative 13. And it's been multiplied by, what is negative 3 plus 2, it's negative 1, so it's positive, alright, so we have positive 1, alright, okay, so I want to use a different color code. So what I do is I replace negative 3 in this, okay? So doing that, we have 4, negative 3 minus 1 multiplied by negative 3 plus 1, alright? So this is negative 12 minus 1, negative 13 multiplied by negative 2. Okay, when you multiply this times this, negative 2. If you multiply the 2, what you're going to have is positive 26. Alright, so since positive 26 is greater than 0, right, so it means that this part, every value here qualifies to be in the x. Okay, so every value beyond negative 2 is part of our solution. Alright, then we're going to test a number between negative 2 and 1 over 4. Right? This is positive 1 over 4, so I can even use 0 in this case. If I put 0, what we're going to have is, erase this. If I put 0 here, and 0, because 0 is in between negative 2 and 1 over 4, we're going to have negative 1 multiplied by positive 1, okay, which is negative 1, but negative 1 is not greater than 0, so meaning this part is rejected. So this is still open because of the greater. If you want, you can test, okay. If you decided to test a value 1 over 4 itself, it will give you 0, okay, because you have 1 over 4 minus 1, alright, then we have 1 over 4 plus 2. Okay, so this is 1 minus 1 multiplied by, this is 9 over 4, alright, so 0 multiplied by 9 over 4 is 0. But is 0 greater than 0? 0 is not greater than 0. So since 0 is not greater than 0, this particular point is not part of our solution either. Right, so now we also want to test values beyond 1/4. We want to test values beyond 1/4. So doing that, what do we get? We want to test values beyond that. Right, so if I pick maybe a positive number, let's say positive 5, okay, or positive 4, pick them nicely. So I'll pick 4, so I'll say 4 here, and we'll have 4 there. Right, so this is 16 minus 1 multiplied by 5, which is simply 15 multiplied by 5. Okay, so I can say 5 there, 75. Okay, so this is 75. Now we know 75 is actually greater than 0, so this is part of our solution. Right, so what is the answer in that case? Okay, so basically speaking, from what we've noticed, we've actually seen that x is not in between -2 and that. So the x is coming from the first one. We said x is greater than 0. Okay, so we had 0 to positive infinity. All right. Then the other one, we started off from negative. As you can see, the solution is coming from here in that direction, right? So we have negative infinity up to -2, but -2 is not part of. Okay, so and right, there's a gap here. So instead of and, we have union, right? So the union here entails that the x values are coming from 1/4 up to positive infinity. Right, so this is how you go about that. Now, if you look at the solution which we have, you actually notice that the answer, right? The answer for the x is therefore in this range. Okay, so x is a member of 0 to infinity, and x is a member. So we're saying x is a member of this 0 to infinity. And x is also a member of negative infinity to -2 up to 1/4 to positive infinity. So that is your answer for that question. Okay, so that's how you basically find questions to deal with that. Okay, next question, let's look at E. Let's look at E. Let's look at E. Okay, so let's look at E. E says x minus 2 to the power 5, 3 minus x, x plus 1, squared should be less than 0. Okay, so So I'll do this one, I'll not do the next one because it's one and the same thing. The only difference is that the sign has changed. It's now looking forward, okay? All right, for this particular question here, it's like they've already factorized for us, so we're simply going to deal with the end result, okay? So they've already factorized, we're dealing with the end result. We're going to say x minus 2, okay? The power 5 is equals to 0, so we have x minus 2. If you take the fifth root on both sides, you'll notice that x is actually equals to 2. Okay, the other one we have 3 minus x is equals to 0, so x is actually equal to 3, because if it goes that side it's negative, negative, negative is positive, so x is 3, and when you have x plus 1 equal to 0, your x is negative 1, right? So these three values are found are my boundary values. So what I've done is I've equated this inequality to 0, right? Then at these points, 2, 3, and negative 1, this particular thing is 0, okay? So if you put 2, this is 0, so 0. And now, if you put 2 here, yes, there are all these 2, 3, and negative 1 makes this inequality as 0, alright? So that is what we have. So can we erase this part? Let me put my values there so that we can make reference to them. So x is 2, x is 3, and x is negative 1, right? So that having been done, the next part that we need to do now is we want to test, right? We want to test. It's not even a want, it's a need to test, right? So it's a definite need to test. So in order for us to test those values which we have, what I'm saying is that these three values are now my boundary values, right? So we basically have this line here, and we have negative 1, we have 2, and we have 3, okay? Right, so if I put negative 1 here, this is going to be 0, but is 0 less than 0? No, so we're saying for x being equals to negative 1, we have negative 1 minus 2 to the power 5, 3 minus 3 minus 1, then minus 1 plus 1 squared is less than 0. You actually notice that this is 0, so 0 is less than 0. But is 0 less than 0? No. So since 0 is not less than 0, this particular value here is not part of the solution. Okay, because 0 is not less than 0. Alright, let's pick a different value. Let's now try to test beyond this negative 1. Let's pick negative 2. Okay, so we're saying now, I want to test this side, okay? So we're saying for x being equals to negative 2, what will this thing be? We'll have negative 2 minus 2 to the power 5, 3 minus 2, then negative 2 plus 1 to the power 2, okay? So if you evaluate that, you actually get a solution. And the number that you have in that case is negative 5,120. Okay, so negative 5,120. If you look at negative 5,120, is it less than 0? Okay, so yes, it is less than 0. So negative 1,520 is less than 0. You actually have this side as part of the solution, right? So others, what they do is they test the signs, okay? They test the signs. Instead of really evaluating the values that are in question, you can test the signs. In doing so, what you will notice is that you have a negative here, you have negative, because a negative to the power odd number is a negative, so you have a negative here. Here you have positive, then here you have negative. Okay, so negative, positive, negative. Alright, so if you follow, you notice that this is -4, okay? -4 to the power 5 is still negative. Then you are multiplying this by -2 there. So basically that is going to be -5, right? So negative, that is going to be -5. Right, then you have -2 plus 1, which is negative. Right, so the final answer becomes negative. The reason is simple. This is +5, this is -1. Squared is positive, so positive times positive is positive times negative is negative, right? So you can actually just use the sign and say, since whatever value it is negative, then it's less than 0. This is another approach that other people use. Alright, so now I'm going to test for a number between -1 and +2. Right, so for a number between -1 and +2, let's consider maybe even 0 can work. Alright. Even 0 can do. Okay. If I choose to pick 0, what will I get? Because 0 is between -1 and 2, so we have -2 to the power 5 multiplied by 3 multiplied by 1. Okay, so in this case, since this is negative, yeah, so that is negative. So negative, this is -2 to the power 5 is 32. Okay, so I don't need the exact value, but I know the sign is negative. So since it's negative, it's going to be that. So we have -32 multiplied by 3, which is 6, 9, -96. So this is -96. All right. So -96 is less than 0, so meaning that part we mark it is part of the solution. Alright, so this is part of the solution. Okay, so I simply picked a value that was in between -1 and +2. Okay, next up, let's pick a value 2 itself. So if I pick 2 as a value, what do you notice? What you are going to have is 2 minus 2 to the power 5, 3 minus 2, then we have 2 plus 1 is less than 0. Okay, that is what you get. So from that we can actually see. From that we can actually see that this is 0. Okay, then whatever we multiply by this would be 0, so 0 is less than 0. Alright, so is 0 less than 0? No. So meaning that part is not part of the solution. Right. Next up, we're going to use a value between 2 and 3. So this is 2. Right, so I'm going to use a value between 2 and 3. Picking a value between 2 and 3. The value between 2 and 3, let's say 5/2. Let's pick 5/2. Alright, so for x being equals to 5/2, what do we get? So this actually becomes 5/2 minus 2 to the power 5 multiplied by 3 minus 5/2 multiplied by 5/2 plus 1. Okay, it's less than 0. Okay, so if you evaluate that, you will notice that your answer is 49/256. 49/256. This is not actually less than 0. So here, this part says no. Okay, so x is not in that range. So x is not in between 2 and 3. It's nowhere between 2 and 3. Alright? So next up, we pick a different value. We pick a value 3 itself. So if I pick 3, what do we get? So 3 is going to be 3 minus 2 to the power 5, 3 minus 3, then 3 plus 1 squared is less than 0. But you know this is 0, so this is the same as saying 0 is less than what? 0, but which is not true. So this is not part of the solution. Alright? That's not part of the solution. Next up, we're going to test for a value beyond 3. Testing for a value beyond 3, let's say example, what value is beyond 3? Let's say 6, huh? Let's say 6, so f of 6, alright, this will give us 6 minus 2 to the power 5, 3 minus 6, right? Then we have 6 plus 1 squared, it should be less than 0. When you find that, you get 150,528 is at less than 0. So you have negative 150,528 as your answer. So now, this is part of the solution. Okay, so that is part of the solution. So what is the answer? All I was doing right now is I was testing, right? So all I've been doing all this while was just testing the values. So now we want to know what is the actual answer. So you will notice that x is actually a member of, you're starting from negative infinity, right? Then up to negative 1, but negative 1 is not included. The union, negative 1 up to 2. Okay, then union 3 to infinity. So this is the value of x. So x is found between negative infinity and negative 1. As you can see from negative infinity up to negative 1, but negative 1 is not included. And it can also be found between negative 1 and 2, negative 1 and 2. X can also be found between 3 and positive infinity. Alright, so that's how you get to that question. So that's the solution for that particular question. Okay, so let's continue and see what else we can find as our solution. So lastly, let's do the last question under tutorial sheet 3. Then we can migrate to tutorial sheet 4. Alright, so last question under tutorial sheet 3. I'm going to erase this. So basically speaking, these values that we found here are what we call our boundary values. Okay, so we test at before and after the boundary value to see if x is part of that range. Okay, and that's how you deal with inequality. So whenever you find an answer is an inequality, it will usually be referred back to this. So this is the reason why we basically taught you sets and set intervals. Okay, the first topic you learned was sets, and the sets had the component called interval sets. Right. So this is the application of those interval sets, so that whenever you are dealing with inequalities, it is not difficult for you to get to the solution. Right. Alright, so lastly, let's look at G. Let's look at G. 31G. 31G. 31G says 2x cubed 2x cubed plus 9x squared minus 6x minus 5 is greater than 0. Okay, now ladies and gentlemen, notice that I deliberately have already taken these things on the other side. Okay, if you look at g itself, this component is on this other side, but now I've taken it on the other side, right? So this is now a cubic function, right? It's different from the one that we found. What is the first thing that we need? We need to find that particular factor that gives us the solution being equals to 0. Okay, so what is the first factor which we can find? Okay, so as we said last time, the factors here, our p is -5. So since the p is -5, the factors of -5 are plus or minus 1 and plus or minus 5, all right? Then our q here is the coefficient of x cubed, which is 2. Okay, so the factors of 2 are plus or minus 1 and plus or minus 2, all right? So we now find p over q, right? P over q, remember p is the constant. The constant here is -5 and q is the coefficient of x cubed, so which is 2. So the factors of 5 are plus or minus 1, plus or minus -5. So there we also have q, which is 2. The factors of q are plus or minus 1 and plus or minus 2. Okay, so now p over q, if you're dividing, you're dividing, so if you divide all these by 1 plus or minus 1, you get 1 plus or minus 1 plus or minus 2, alright? Then if you divide these two values, plus or minus 1 and plus or minus 2, over p, in this case p is 5, you get 2, yes, you actually get plus or minus 2, it's p over q, okay? So since it's p over q, plus or minus 5 over 2, and you, so basically speaking, you have plus or minus 1, 1 over 2, okay, let's start with 1 over 2, then you have plus or minus 5 over 2, right? So meaning that the factor that I'm looking for can come from any of these, okay? So the factors that we're looking for can be any of these, all right? So let's try maybe just the first one, which is 1, okay? We'll try positive 1. If we put positive 1 there, what do we get? All right. So would this give us 0? So positive 1 will be 2, 1 to the power 3 plus 9, 1 squared minus 6, 1 minus 5. All right. So we have 2 plus 9 minus 6 minus 5, which is 0. Alright, because now 9 plus 2 is 11 and -6 minus 5 is also 11. So the first factor that we have is basically positive 1, okay? But the actual factor is x minus 1. Okay, so the actual factor is my x minus 1. Okay, so that's the actual factor in question. So we're now going to use the synthetic division method after this. Okay, so by use of the synthetic division, what we are now going to have is, we're going to basically say, we found x as 1, right? So we're going to write 1, 1, 1 here, then the constants, the constants of the coefficients of the cubic function or the cubic polynomial, or the polynomial in this case, we have 2, we have 9, we have -6, and we have -5. All right, so that is that which we have. All right, and so basically speaking, if you use this, the next thing is we're going to first bring down the 2. 1 times 2 is 2, we said we write the 2 here, 9 plus 2 is 11, right? 1 times 11 is 11, this is positive 5, then 1 times 5 is 5, okay? So that is going to give us a 0. So the quadratic equation that results from this is given as qx, and that quadratic equation in this case is 2x squared plus 11x plus 5. Okay, so that is the quadratic equation that we have as the resulting quadratic equation. Okay, so now we need to solve that particular quadratic equation to find the zeros in question. So let's solve the quadratic equation. Okay, so solving the quadratic equation, qx is given as 2x squared plus 11x plus 5. The product here is 10. The sum is 11, and the factors we have 10 and 1 and 10. So 1 and 10. Right? So qx is now 2x squared plus x plus 10x plus 5, and this is 2. X is common. We have 2x plus 1 plus, so the x is common here, okay, plus 5 is common. We have 2x plus 1, okay, we have x plus 5, we have 2x plus 1, right, then as a qx. So if we factorize this thing, okay, so if we were to factorize this thing, it would actually end up being like this. So we'll have the actual question now is x minus 1, x plus 5, 2x plus 1 is actually greater than 0. Okay, so this is basically what we have as our final solution. Okay, that is what we have as our final solution. Okay, so if I equated these to 0, what will we get? So it's like now saying x minus 1, x plus 5 is 2x plus 1 is equals to 0. So x is 1. X minus 1 is equals to 0, so x is equals to 1. The next one we have x plus 5 is equals to 0, so x is equal to negative 5. And lastly, we have 2x plus 1 is equals to 0, so x is equals to 2x is equals to negative 1 over 2, so x is equals to negative 1 over 2. Okay, so these values which are found there are what we're calling our boundary values, right? So those values which we found there are simply our boundary values. So we're saying x is equals to 1, x is equals to negative 5, and x is equals to negative 1 over 2. All these are simply our boundary values. Okay, so we're going to use our boundary values now for us to get to the solution. So I'll erase this part. Okay, so I'm going to draw a line as before, and we're going to have negative 5, negative 1 over 2, and lastly positive 1. Okay, that is what we are going to have. Alright, so now we want to test at negative 5. Let's start with negative 5. Testing at negative 5, we have for x being equals to negative 5, we're going to have negative 5 minus 1, negative 5 plus 5 and 2 negative 5 plus 1 is greater than 0, right? So this is 0 is greater than 0. But is that true? Is 0 greater than 0? No. So this part is open, okay? So not part of, right? Let's pick a different value. Let's pick a different value. Right, so the next value which I'm going to pick is something that is beyond the negative number which we have. Alright, so for something beyond that, let's say we pick negative 6, okay? Let's say we pick negative 6. If we pick negative 6, we have x is equal to negative 6. So from here we have negative 6 minus 1 multiplied by negative 6. Let's be right on that side. Okay, so negative 6 minus 1 multiplied by negative 6 plus 5 multiplied by 2 negative 6 plus 1, right? This should be greater than 0. Your final answer will be negative 77 and it's greater than 0. Okay, but is negative 77 greater than 0? No. So negative 77 is not greater than 0, so meaning that this side is not part of the solutions we're looking for. Okay, next up we're going to pick a value that is in between, right? Next up we're going to pick a value that is in between. A value in between, in this case, let's say we pick f of between negative 5 and negative half is negative 1, right? So let's pick negative 1. So we have negative 1. So we're saying for x being equals to negative 1, you're going to have negative 1 minus 1 multiplied by negative 1 plus 5 multiplied by 2 negative 1 plus 1, and this should be greater than 0. Alright, so negative 2 from here multiplied by negative 1 plus 5 is 4. Okay. 2 times negative 1 is negative 2 plus negative 2 plus 1 is negative 1. Yes, negative 2 plus 1 is negative 1. Alright, so if you are to multiply those three, you actually end up having positive 8. Okay, so 2 times 4, 8, negative, negative, positive, so it's 8. Is this 8 greater than 0? The answer is yes. So since 8 is greater than 0, this part is part of our solution, right? Next up, we are going to test a different value, right? So next we're going to test a value that is negative half itself, right? So testing for negative half, we want to know what is going to happen, all right? We want to know what is going to happen. So we want to know what's going to happen on this one end, right? Alright, so for negative half, you have x minus 1 over 2, then 1 over 2 negative plus 5, 2 negative 1 over 2 plus 1. Okay, so 2 times negative half is negative 1. Then negative 1, yes, this is negative 1 plus 1, 0. So meaning, is 0 greater than 0? The answer is no. So since 0 is not greater than 0, this part is open. So now we're going to test the value between negative half and 1. Alright? So if we want, we can test 0. Alright, let's just use 0. Let's just use 0. If we're going to use 0, what is that thing going to become? Okay, so if we're going to use 0, we're going to have 0 minus half, 0 plus 5, then 0 plus 1, greater than 0. So negative half multiplied by 5 multiplied by 1 should be greater than 0. Alright? So that's basically what we're going to have. If we find the final of this, you will notice that negative 5 over 2 is greater than 0, but which is not true. So meaning this part has been rejected. Okay? So that part has been rejected. Right, so that part has been rejected. Lastly, okay, so lastly, we want to test a number that is beyond positive 1. Okay, so testing for a number beyond positive 1. For a number beyond positive 1, let's say we pick positive half, right? Let's say we pick positive half. What do we get? Okay, if we pick positive half, beyond 1, positive half. Actually, let's even just, positive half is fine. But we can pick a number without a fraction. Let's say we pick positive 2, right? So we're going to have this as 2 minus 1 multiplied by 2 plus 5 multiplied by 2 plus 1. And this should be greater than 0. Okay? So as we can see, this is 1 multiplied by 7 multiplied by, this is 4, 5 is greater than 0. Okay? So basically speaking, if we check the final answer ends up being 35. Okay, so final answer ends up being 35. So we have 35 is greater than 0. Okay, so 35 is greater than 0. That is true. Okay, so this is part of our solution. So since 35 is greater than 0, the 35, that part is part of our solution. Okay, so what is our x then? Our x is therefore a member of, remember that this part is not part of, so negative 5 comma negative 1 over 2 union. This is not part of, this is not part of, then we're starting from 1 to positive infinity. So this is the solution, right? So the solution is we're coming from negative infinity, negative infinity to negative 5, x is not there, so, but it is between negative 5 and negative 1 over 2. These two are open, so we open, alright? So this is why we've written an open interval there instead of a closed interval. So we have negative 5 comma negative 1 over 2 union 1 comma infinity. Alright, so that is the final answer. Okay, so that is the final answer. Okay, so this ends tutorial sheet 3. That ends tutorial sheet 3. If you are going to deal with a different one, let's say maybe this changes to less or equal to, alright? If that changes to less or equal to, when you'll be solving your solution, you'll notice that this will actually swap anything that was cancelled this time. So this now will be open because it's greater than, this will be closed. This was, so this will be closed. This, yes, this will be closed. This is now going to be no, and this is going to be closed, right? So for a solution that is less or equal to 0, okay, so try this one, and see if you can guess to this answer which I've written here. So for this one, less or equal to 0, this is what you're going to have as a solution. So basically speaking, this is going to be open, right? This is going to change entirely. It's going to be open, negative infinity, comma negative 5 closed, right? Then union, negative 1 over 2, comma 1 closed. Okay, so this is going to be your answer. All right, so if you're going to go the other way around, you will note that this is going to come out at your answer. So try it and see if you can get this. Test your values, and then it should give you this as your final answer. All right, this should give you as your final answer. Okay, so ladies and gentlemen, that marks the end of our tutorial, right? For those that have not yet subscribed to the channel, subscribe. Okay, so this was tutorial sheet 3, and we've done up to question 31. All right, we've done up to question 31, and the last part was dealing with inequalities. So whenever you're dealing with questions to do with inequalities, as we have said, it's different from an equal sign. There's always the need for you to test the critical value. So you have these values which you found as negative 5, negative half, and one of these are called your zeros or your critical values. So we test at the critical value, before the critical value, or beyond the critical value. Okay, so if you notice that we are testing at, before, after, at, before, after, at, before, after. All right, man. The beauty is that once you test for before negative 5, then you've actually tested for after negative 5. So you will notice that you just need to test here once, but you also have to check the boundary values, okay? As a statement, you will notice that whenever you have an inequality having an equal to sign, the critical values which you find will usually be part of. I don't want to say always, but will always be part of, okay, they'll always be part of the solution. The critical values will always be part, as long as you have an equal to 0, okay, the critical values will always be part of. But if it's strictly less or strictly greater than, then you'll notice that the critical values will not be part of, right? So that marks the end of tutorial sheet 3, unless we do a review in tutorial sheet 3. Have a good day.